Today's speaker is Violina Popova. Is a seasonal software developer with a focus on a mobile app development dedicated to providing seamless cross-platform experience. Her journey in the tech industry began in consulting before the transitioning into programming. With expertise in React, React Native, TypeScript, Firebase, and Next.js, she excels in both mobile and web application development. So as I mentioned, if you're having a question, we can address them after the session. And thank you so much. I'm going to stop sharing. Violina, you can take the stage. Thank you so much.
Thank you, Mariya. Okay. I hope you're seeing my screen. Okay, just a second. Hello, everyone. I'm super excited that you are here. Over the next 2 months, we are going to embark on an exciting and incredibly valuable journey into the world of design patterns in JavaScript. This isn't just a quick overview. We are really going to dive deep. We've got 4 dedicated sessions lined up, and each building on the previous one to explore these powerful concepts. Our goal is to equip you with the knowledge and tools to write more robust, maintainable, and scalable web applications. To support our learning and keep the conversation going between sessions, we've set up a dedicated Slack channel. It's a design pattern study group. I sent the link in the chat before, and this will be our go-to spot for asking questions, sharing insights, and collaborating with others. Please jump in there if you haven't already. So today is our first session. We'll kick things off by laying the groundwork, understanding exactly what design patterns are and why they are so crucial. And then we'll immediately dive into some foundational ones, the factory pattern, the prototype pattern, and the module pattern. This will give us a fantastic starting point for applying these concepts, and I'm really looking forward for our time together. Let's get started. You might have already heard them before, or you're familiar with some of them, but at its core, a design pattern is simply a reusable solution to a commonly occurring problem in software design. Think about building a house. You wouldn't invent a new way to build a door or window every time, right? You would use proven architectural blueprints and techniques. Design patterns are precisely that for software. They are generalized templates or recipes that provide a structured approach to a problem. They are not a specific piece of code you copy and paste. Rather, they are conceptual frameworks that you adapt and implement to fit your unique needs in JavaScript. The power of using this pattern is immense. They fundamentally improve the quality of your code. This means your applications become far more maintainable and easier to fix bugs and add new features. They become more scalable, capable of growing and handling increased demands. And crucially, they significantly boost readability, making your code's intent clear to anyone looking at it, including your future self. Ultimately, design patterns promote best practices and consistency across your projects. They also serve as the common language among developers. When you say you're using a factory pattern, for instance, other developers instantly understand the general structure and purpose, making collaboration much smoother. Design patterns are categorized into 3 main types, based on their primary purpose. Creational patterns. These deal with object creation. Structural patterns. These deal with object composition and relationships. And behavioral patterns, these deal with object communication and interaction. Let's see first the creational patterns. As the name suggests, these patterns are all about how objects are created. They aim to abstract the instantiation process, making the system independent of how its objects are created, composed, and represented. The key goal here is to provide ways to create objects that are flexible, controlled, and hide the creation logic from the client. Some common creational patterns include factory, singleton, builder, prototype. Next, we have the structural design patterns. These patterns are concerned with how classes and objects are composed to form larger structures. They focus on simplifying the relationships between entities, making systems more organized and flexible. The key goal here is to simplify the structure by identifying a simple way to realize relationships between entities. Some popular structural design patterns are adapter, bridge, proxy, decorator. And finally, we have the behavioral design patterns. These patterns are all about how objects communicate and interact with each other. They focus on algorithms and the assignment of responsibilities between objects, making interactions more flexible and robust. The key goal of behavioral design pattern is to improve the communication and interaction between objects. And some widely used behavioral patterns are observer, state, iterator, template method. The obvious question now is, with so many options, how do you pick the right one for your specific problem? It can feel a bit overwhelming at first, but there are some practical guidelines. First, you have to understand the problem deeply. Before you even think about design patterns, clearly define the design issue you're trying to solve. Are you struggling with flexible object creation? Are your classes too tightly coupled? Is communication between objects chaotic? A clear problem statement is your first and most crucial step. The second thing is to know your patterns, the basics anyway. You don't need to memorize every pattern immediately, but familiarize yourself with the common patterns and their core goals. Knowing that factory helps with object creation or an observer handles one-to-many communication will give you a starting point when facing a new challenge. The next thing is to don't force it. Simplicity first. This is a critical piece of advice. Not every problem needs a design pattern. Sometimes a simpler, straightforward solution is genuinely better. Over-engineering with patterns can introduce unnecessary complexity, making your code harder to understand and maintain. If it's simple and it works, stick with it. The next advice is to start simple, then refactor. A great strategy is to implement a basic solution first. Get it working. Then, if you see signs of complexity, tight coupling, or lack of flexibility, that's when you consider if a design pattern can help you refactor and improve the existing code. Patterns are often best applied as solutions to emerging problems, not as a starting point for every line of code. And the last thing is iterate and learn. Software design is a rarely one-shot deal. It's an iterative process. You might apply a pattern, learn from its benefits or its challenges in your specific context, and then refine your approach. Embrace this learning curve. Every pattern you implement helps you build your design intuition. Now that we have a clearer picture of what design patterns are, let's start seeing some of these patterns in action. Today, we are going to dive into some foundational creational patterns and essential component logic patterns Specifically, we'll explore the factory, prototype, and module patterns. These are fundamental building blocks that will immediately show you the practical benefits of applying design patterns in your JavaScript code. Let's start with the factory pattern. This is a creational design pattern, which means it deals with an object creation mechanisms. The factory pattern provides a way to create objects without exposing the creation logic to the client. In simpler terms, it defines a factory that is responsible for creating objects. Why would we use this? Well, it offers several advantages. First, it abstracts the object creation process. The client code doesn't need to know the details of how an object is created. It just asks the factory for it. This makes the code more flexible because you can easily add new types of objects without changing the code that uses them. It also decouples the object creation from the rest of your application, and it makes your code easier to maintain because all the object creation logic is centralized. Think of it like a car factory. You don't build the car yourself. You tell the factory what kind of car you want, a sedan, an SUV, a truck, and the factory handles the rest. You don't need to know how the engine is built or how the seats are installed. You just get the finished product. The factory pattern can be very useful for different component creation in larger applications. Though, like any pattern, its application requires careful consideration. In the context of React apps, here's why and when it can be beneficial. The first thing is dynamic component rendering. In large applications, you often have scenarios where you need to render different types of components based on data, user roles, or certain conditions. A factory can centralize the logic for deciding which component to render and how to instantiate it. As an example, a dashboard that displays various widgets, charts, table, text block based on configuration data. A component factory can take a widget type and return the appropriate React component. The next thing is abstraction of component creation logic. When component creation involves complex setup, dependencies, or variations in props, a factory can encapsulate this complexity. The consumer of the factory just asks for a component without needing to know the intricate details of its construction. And as an example, if certain components always need specific default props or are wrapped in higher order components based on some logic, the factory can handle this automatically. The next benefit of using a factory pattern in larger apps is reduced coupling. It decouples the component consumer from the concrete component implementations. If you decide to refactor or replace a specific component, the consuming code doesn't necessarily need to change, only the factory's internal logic. The next thing is centralized management of components. For a large number of related but distinct components, a factory provides a single point of entry for their creation. This makes it easier to manage, audit, and modify how these components are instantiated across the application. And the final benefit is extensibility. Adding new component types often just means extending the factory's internal logic, rather than modifying multiple places where components are directly instantiated. This adheres to the open-closed principle. Good use case of a factory pattern is when you have a family of components that share a common interface or purpose but have different implementations. when the decision of which component to render is dynamic and based on external data or runtime conditions. When the creation of a component involves significant setup logic or dependencies that you want to hide from the consumer, and for plugins or extensible architectures where you need to dynamically load and render components. These were the benefits. Now let's see the potential drawbacks and when not to over-engineer. Over-engineering for simple cases, for example, applications, simple applications or straightforward component rendering, introducing a factory can add unnecessary complexity and boilerplate code. Direct import and rendering are often sufficient. Increased indirection. The factory pattern introduces an extra layer of abstraction, which can sometimes make debugging slightly more challenging if you're not familiar with the pattern. And maintaining the factory. The factory itself needs to be maintained and updated as the new component types are added or existing ones change. Now let's see some example of factory. And I have created this simple create animal factory. Let me just uncomment. Okay, so in this code, I just want to make sure that the code is visible for all of you. I'll just zoom it a bit. Okay, so in this code, the create animal function acts as our factory. Its entire purpose is to create new animal objects. Here's how it works. Const create animal defines a function named create animal. It uses object structuring in its parameters, species, name, age. This means when you call create animal, you're expected to pass in an object with species, name, and age properties. It then directly extracts those values for use inside the function. The syntax is an arrow function that implicitly returns an object. This object is the new animal instance. The return object, when create animal is called, it constructs and returns a new plain JavaScript object with the following properties and methods. Species. This property is set to the species value that was passed into the factory. Name. This property is set to the species value that was passed in. Age. This property is set to the age value that was passed in, and description is the method that when code returns a string describing the animal using its name, age, and species. Even though this is a very simple example, it embodies the core principles of the factory pattern, encapsulates creation logic. The create animal function handles the entire process of creating an animal object. You don't directly write species, dog, name, body, age, tree, description, function every time you want an animal. Instead, you delegate that responsibility to the factory. The next thing, it provides an interface for creation. The create animal function serves as a clear single point of entry for making new animal objects. You just call it with the required properties, and it hands you back a fully formed animal. And finally, it hides implementation details. The code that uses create animal, the client code, doesn't need to know the internal structure of the animal object or how the description method is implemented. It just knows that create animal will give it an object that has species, name, age, and the description method. And to summarize, the factory pattern is useful when we have to create multiple smaller objects that share the same properties. A factory function can easily return a custom object depending on the current environment or using specific configuration. And I will just zoom out, comment this code, and go back to the slides. Now let's move to another foundational pattern, and this is the prototype pattern. This pattern is particularly important in JavaScript because it directly leverages one of the language's core feature, the prototype chain. At its heart, the prototype pattern is about creating new objects by cloning or inheriting from an existing object, which we call the prototype. This is incredibly powerful for sharing common properties methods among many objects of the same type. The key idea here is efficiency. Instead of each object having its own duplicate copy of a method, for example, they all share a single instance of that method located on their prototype. When you try to access a property or method on an object, JavaScript first looks directly on that object. There are few key reasons why this pattern is so powerful and beneficial in our application. First and foremost is about memory efficiency. By allowing objects to share methods and properties through their prototype, we avoid creating duplicate copies of the same functions for every single instance. Imagine hundreds of thousands of objects. This can lead to significant memory savings and better performance. Secondly, it offers incredible flexibility and extensibility. As we saw, you can dynamically add new methods or properties to a prototype, and all existing and future instances of that type will immediately gain that new functionality. This allows for every adaptive and extensible code. And third, the prototype pattern is excellent for dynamic object creation. It provides a robust way to create new objects based on existing templates, especially when the exact type of objects you need to create might not be known until runtime, or when you want to avoid tightly coupling your creation logic. And finally, and perhaps most importantly in JavaScript, using prototype pattern means you are leveraging the language's core inheritance mechanism. Understanding and utilizing prototypes allows you to write more idiomatic, performant, and maintainable JavaScript as you're working with how the language was fundamentally designed. Let's see an example of the prototype pattern. Here we have our animal prototype object with shared methods. Prototype pattern is about using one object as a blueprint for others. It enables object delegation, object inherit directly from other objects. Animal is our prototype object. It defines reusable methods like speak and info. Parrot is a concrete object with its own properties, name, species, etc., but inherits behavior from animal. Object set prototype of links parrot's prototype chain to animal, allowing it to use the methods in animal. This avoids duplication and helps keep shared logic in one place. All right, we've seen how the prototype patterns work. Now let's recap the fantastic benefits it brings to the table. making it a valuable tool in your design pattern toolkit. First, memory efficiency. This is a huge win, especially in applications where you're creating a lot of similar objects. Instead of duplicating methods on every single object instance, they're all shared from a single location on the prototype. This drastically reduces your application's memory footprint, leading to smoother performance. Next is all about code reuse. Since the methods live on the prototype, you define them once, and every object that inherits from that prototype gets access to them. No need to rewrite the same logic over and over again for each new instance. A really powerful aspect is dynamic behavior changes. Imagine you need to update a shared method within the prototype pattern. You simply modify the method on the prototype itself. Instantly, every object that inherits from that prototype gets the updated behavior. You don't have to go through and update each individual object. The pattern also offers remarkable simplicity in certain scenarios. While we often use ES6 classes, the core prototype pattern allows you to link objects directly without needing formal class definitions or constructors. This can feel very natural in JavaScript, which at its heart is a prototype-based language. And finally, for performance-critical scenarios, you might find faster instantiation. Creating new objects by leveraging the prototype chain can often be quicker than the overhead involved with class constructors, especially when you are dealing with very lightweight object blueprints. While the prototype pattern offers some compelling advantages like any design pattern, it's not a silver bullet. There are definitely some drawbacks and potential pitfalls we need to be aware of. One of the biggest challenges, particularly in larger applications, is the confusing inheritance chain. As we saw, JavaScript walks up the prototype chain to find properties. If these chains become very long, deeply nested, or circularly referenced, they can become incredibly complex and difficult to debug and reason about. Tracing where a particular method or property is coming from can be a real headache. Next, the prototype pattern in its raw form lacks encapsulation. Because all objects share the same prototype, there is a risk. If someone accidentally modifies or even deletes a method directly on the prototype at runtime, that change immediately affects all objects that inherit from it. This can lead to unexpected bugs and makes your code harder to predict. There's also limited flexibility in certain areas. For instance, the traditional prototype model doesn't inherently support private properties in the same way that some class-based languages do. Also, if you want to override a method or just one specific instance of an object without affecting all other instances that share the same prototype method, it requires careful handling to ensure you're not inadvertently changing the shared behavior for everyone. For developers coming from other object-oriented languages like Java, C# or Python, where class-based inheritance is the norm, the prototype system can feel counterintuitive at first. It's a different mental model, and it takes time to get used to how inheritance and object creation truly work in JavaScript. And finally, a technical point. While powerful, the object set prototype of method, which allows you to change an object's prototype after it's created, is generally discouraging performance-critical paths. Modern JavaScript engines optimize heavily based on predictable object shapes, and dynamically changing an object's prototype can disrupt these optimizations, leading to performance hits. So while understanding and using prototypes is essential with JavaScript, it's crucial to be mindful of these potential drawbacks and choose the right tool for the job. Now, let's shift the gears to the module pattern. This pattern is fundamentally about encapsulation and privacy, which are crucial concepts in software design. At its core, the module pattern allows you to group related variables and functions together, creating a self-contained unit of code. The magic here is that it protects these internal variables and functions from interfering with or being interfered by other parts of your application's global scope. The main idea is to define a private scope. Everything inside the scope is hidden from the outside world unless you explicitly decide to expose it. You only present a public interface or an API that other parts of your code can interact with. Historically, before ES modules were widely adopted, this was primarily achieved using immediately invoked function expressions, combined with closures. This created that private sandbox for our code. You can think of it like a black box. You know what goes in and what comes out, but the complex machinery inside is hidden. You don't need to understand the internal workings to use it, and you can't accidentally break its internal components. So what are the compelling reasons to embrace the module pattern? It brings a host of significant benefits to our JavaScript applications. And first and foremost, it's encapsulation and data privacy. This pattern allows us to truly hide implementation details. Variables and functions defined within a module are private by default, meaning they can be accidentally accessed or modified from outside the module. This protects your code's integrity. This naturally leads to avoiding global scope pollution. In JavaScript, it's easy for variables to leak into the global scope and cause naming conflicts, especially in larger projects. The module pattern prevents this by keeping all its internal working isolated, significantly reducing the risk of unintended overrides. It also greatly contributes to improved code organization. By grouping related functionality into self-contained modules, your codebase becomes much more structured, readable, and easier to navigate. Each module has a clear responsibility. This organized and encapsulated structure directly translates to enhanced maintainability. When you need to make a change or fix a bug, you know exactly which module to look into. Changes within a module's private scope are less likely to break other parts of your application, simplifying updates and debugging. And lastly, modules are excellent for creating a single source of truth. If you have shared configuration data or state that needs to be accessed by and managed consistently across different parts of your application, encapsulating it within a module ensures there's one controlled place for that information. While the module pattern is powerful, it's essential to acknowledge its limitations and drawbacks. As I said earlier, no pattern is a silver bullet, and understanding the cons helps us to choose wisely. One notable challenge can be debugging. Because internal variables and functions are private, inspecting their state directly in the browser's developer tools can be more difficult. You often need to expose them temporarily for debugging purposes or rely on logging, which can add complexity. Another point to consider is the risk of over-encapsulation. Sometimes a strict adherence to hiding everything can make your code harder to test or extend. If you need to expose functionality for testing, you might need to add specific methods just for that purpose or mock parts of the module. It's also important to remember that the privacy achieved with the module pattern relies on closures, not a true language level private keyword like some other languages have. While highly effective, it's a convention. Though it's worth noting that newer JavaScript versions do have private class fields or classes, which is a different mechanism. For simpler scenarios, the pattern can introduce increased boilerplate, especially when relying on immediately invoked function expressions for every small piece of logic. The setup can feel a bit heavy for what you're trying to achieve. While not a direct drawback of the module pattern itself, a related point is that methods like object.setPrototype, of which can be used to dynamically alter an object's prototype, and thus its module-like structure is used creatively, can actually have performance consideration. Modifying prototypes at runtime can disrupt JavaScript engine optimizations. And finally, perhaps most critically for most modern JavaScript, the module pattern in its original form is less relevant with modern JavaScript. The introduction of native ES modules imported and exported with import and export keywords provides a more intuitive, performant, and standardized way to achieve modularity and privacy without the need for manually invoke wrappers. Similarly, private class fields offer direct private members within class contexts. This pattern is still important for understanding JavaScript's history and core concepts, but the direct ES modules are now generally preferred for new code. Now I have an example for the module pattern. So let me explain this example. We have the animal creator function. And this is the core of the classic module pattern. The function is defined and then immediately executed. This creates a new isolated scope for everything inside it. Variables and functions are declared here, like next animal ID, and generated, and this is the private scope. We have private members, next animal ID, and generate ID. Next animal ID is a variable to keep track of the next unique ID for an animal. This state is private to the animal creator module. No code outside this module can directly read or modify next animal ID. Generate ID is a private helper function that generates a unique ID. It uses next animal ID and increments it. Since it's not part of the returned object, it's also private. The public API returns an object. This return object is the public interface for our animal creator module. Create animal This is the only method exposed to the outside world, and it's how you interact with the module to create new animal objects. When createAnimal is called, it can access and use the private NextAnimal ID and generate ID function because of closure. The inner createAnimal function remembers the scope in which it was created. And for usage, we assign the return public API object to const_animal_create. Now we can call animal creator.createAnimal to create new animal instances. Each animal will get a unique ID generated by the private generate ID function, and the next animal ID counter will be safely managed internally by the module. Attempting to access animal creator.nextAnimalID or animal creator generate ID directly from outside the module will result in undefined or an error demonstrating the privacy. This simple module effectively encapsulates its internal state and logic, exposing only the necessary createAnimal method, preventing pollution of the global scope and protecting its internal workings. And that brings us to the end of our first deep dive into design patterns in JavaScript. Today, we laid the groundwork by understanding what design patterns are and why they are essential for writing more robust, maintainable, and scalable applications. Remember, this is just the beginning of our journey. The best way to solidify this knowledge is to practice. Try implementing these patterns in your own code. Experiment with the examples and see how they can solve problems you face. Don't forget to join our dedicated Slack channel, Design Pattern Study Group. This channel is there for you to ask questions, share your code, discuss challenges. We are also going to prepare some homework for you and continue the learning with your peers between sessions. Please jump in there if you haven't already, and we are really looking forward to seeing you all for our next session, where we'll build on these concepts and explore even more.